Plant a crop once, and you can extract up to 200 tons of fresh biomass per acre every single year for 8 consecutive years. This is Super Napier grass. By rapidly growing to heights of over 4 meters, it generates a massive volume of organic material, effectively turning traditional agricultural land into a dedicated feedstock pipeline for commercial biogas production. Achieving this specific output requires 4 things: a precise count of starter stems, heavy-duty beat plowing equipment, a base layer of natural compost, and a reliable water source to initiate early growth. Mastering the early life cycle of this plant allows you to lock in a self-sustaining, high-cellulose energy supply for nearly a decade. Step 1 starts in the dirt. The root system needs room to expand downward. Before planting, the land must be turned using an iron plow to dig deep, specifically 15 to 30 centimeters down into the topsoil. Before the final plowing pass, you need to lay down a heavy nutrient base. This requires 10 tons of manure, mixed with azospirillum and phosphonates, and potassium-rich ash, then folding it evenly into the soil. Relying on these natural fertilization methods immediately improves long-term soil health. Because the soil retains its natural biology, you can reduce the application of synthetic nitrogen fertilizers by a full 25%. With the soil prepped, the planting geometry must be exact. Stems are inserted on a strict grid measuring 90 centimeters by 60 centimeters. At this spacing, a single acre will require exactly 10,000 to 12,000 individual stems. The sequence here is strict. The soil must be thoroughly watered and loosened first. Only then do you insert the stems along those 60-centimeter intervals. Warning tone: if you plant in dry or excessively loose dirt, the roots will fail. You must pack the wet soil tightly around the nodes of the stem to properly induce rapid root germination. Executing that deep plow and packing the nodes tightly ensures the crop establishes a deeply anchored root system, surviving the entire 8-year extraction cycle. Early weed control is mandatory to prevent stunted growth. You must clear the field of weeds at exactly day 30 and perform a second sweep at day 45 if necessary. Immediately following these weeding phases, the soil requires a process called extinguishing. This means introducing another heavy round of nutrient enrichment directly into the cleared soil, so the crop can absorb it without competition. To maintain rapid plant growth over the long term, this specific nutrient enrichment process must be repeated every 150 days. By day 80, the grass reaches a biological tipping point. The canopy grows so tall and dense, it completely blocks sunlight from reaching the ground. This entirely eliminates the need for any manual weeding going forward. Water the crop on the 3rd day after planting, and then settle into a cycle of every 8 to 10 days. The crop is highly resilient, able to maintain its growth even when irrigated with wastewater or highly saline water. Putting the heavy labor in during those first 45 days pays off. Once the self-sustaining canopy closes, it traps soil moisture and eliminates weed competition, drastically lowering your long-term operational costs. The first harvest window opens between 75 and 80 days. When extracting the yield, the plant must be cut completely flat, flush along the ground level. After that initial cut, the extraction rhythm accelerates. Subsequent harvests occur strictly every 45 days, providing 8 full crop cycles per year. To keep the field productive, you have to perform structural maintenance every 2 to 3 years. This involves manually reducing the radius of the crop base to maintain a clean 3 by 2 foot stem bar. Immediately after every harvest, apply 30 kilograms of nitrogen to the soil. This guarantees the remaining root system has the fuel to rapidly generate the next 45-day yield. Under no circumstances should you apply store-bought chemical pesticides. Chemicals severely decrease the plant's 8-year lifespan, and they will actively poison any livestock if the grass is sold as fodder. Treating the crop exclusively with natural pest stimulants protects the biological integrity of the biomass, ensuring it remains safe and highly productive for both agricultural and energy markets. This table details the gross composition of fresh Napier grass. Notice the carbohydrate and fiber percentages. The mature plant contains 35 to 39% cellulose and 19 to 23% xylan. With relatively low lignin, this structure breaks down very efficiently inside an anaerobic digester. Inside the digester, the plant's tough, fibrous walls are stripped away, converting the organic matter directly into simple monomeric sugars via hydrolysis. This chart compares resulting methane output. Those monomeric sugars provide a highly digestible substrate for microbial activity, meaning the bacteria consume the plant matter rapidly, generating massive volumes of methane gas. That cellular breakdown is the entire goal. 8 years of specific spacing, watering, and cutting turns a simple, fast-growing grass into a highly efficient biofuel, ready for transport and commercial use. By executing the deep plow and managing the canopy, you create a naturally defended agricultural engine producing predictable, high-energy yields year-round. Because the crop regenerates itself every 45 days, the total lifespan of the plant yields an energy output to input ratio of 25:1. To get started, secure your initial stem supply of 10,000 units per acre and begin testing your topsoil for that critical 30-centimeter deep plow. Cultivating Super Napier provides a steady, high-cellulose feedstock, acting as a reliable, long-term pillar for decentralized renewable energy production.